Hello, you're welcome to Skyline Tutorials, where learning is made simplified and understanding is better. In Skyline, we set a pace in every exam that any student or candidate would encounter. Welcome to Skyline 90 Days to JAMB tutorial for every science student. Nonetheless, this tutorial sets a platform and it is a recommended tool for secondary and tertiary level students in preparation for any terminal or semester exams respectively. Ladies and gentlemen, let the journey begin. So, you're welcome to day 2 of the Skyline 90 Days to JAMB Physics. For today's episode, we'll be considering the kinetic theory of matter. Kinetic theory of matter. We'll also be considering the kinetic theory of gases and the branches of physics. We'll also cover some questions regarding the previous episode and this. So let's begin with the kinetic theory of matter. Kinetic theory of matter. The word kinetic is referred to as movement, okay, or motion. So kinetic energy is energy possessed by a body by virtue of movement. So this theory is related or is in relation to the kind of movement that matter undergoes. Kinetic theory of matter, the kind of motion or movement that matter undergoes. Are we okay? So let's look at this. The first kinetic theory of matter says that matter is made up of tiny particles called atoms or molecules. And these atoms or molecules are in incessant motion, or you can say they are in constant motion. Matter is made up of tiny particles called atoms or molecules which are in incessant or constant motion. That's what the first kinetic theory of matter postulates. The second is that these particles moves at varying speed. So these particles moves at varying speed. The first is that matter is made up of tiny particles. The second is that these particles, they move at varying speed. The degree to which they move differs from particles to particles. The third is that the mean energy of these particles is their average kinetic energy. The mean energy of these particles is their average kinetic energy. The fourth is that temperature is the measure of the average kinetic energy of the molecules. An increase in temperature will increase the kinetic energy of these molecules. So an increase in temperature increases the kinetic energy of these molecules. The first is that matter is made up of tiny particles called atoms and molecules which are in incessant motion. The second is that particles moves at varying speed. These particles that are in the state of matter moves at varying speed. The mean energy, what does mean means? Mean means the sum of all of the energies that are acting in these particles is the average. So let's say the energies are, let's say, 3 joules, 5 joules, and then 1 joule. Okay, so for us to get the mean energy would be the sum of all of these energies divided by the number of energies. There are 3 energies here. We sum it and then divide it by the number. So we have 3 joules plus 5 joules plus 1 joule all over. How many energies do we have? 3. So this is 3 plus 5, 8 plus 1, 9 plus divided by 3 would give us 3 joules. So the mean of the energies is the average kinetic energy. So this is the average kinetic energy of these energies. That's what that means. An increase in temperature will increase the kinetic energy between these particles in the state of matter. Take note of it. So this is the kinetic theory of matter. Note that they are all talking about motion because they are the kinetic motion theory of matter. So this is the assumptions for the postulate. The next we'll look at for this episode is the kinetic theory of gases. Let's quickly look at it. So basically, there are 5 kinetic theory of gases. The first is that the molecules of a gas are in constant random motion. The molecules of a gas are in constant random motion, colliding with one another and with the walls of the container. So this is a container, for example. The molecules of a gas are in constant random motion. They are constantly in motion and they move haphazardly. They collide with one another and with the walls of the container. So that's the first assumption for the kinetic theory of gases. The molecules of a gas are in constant random motion, colliding with one another and with the container. Take note of that. The second kinetic theory of gas is that the collisions of these molecules are elastic. The collisions are elastic. What does it mean for something to be elastic? Returning back to its usual state. Okay, so when something is elastic, it has the ability to return back to its usual state. So when these two molecules collide together, they return back to their state. So the collisions are elastic. When they collide with one another, they return back to their state. So they are entirely elastic. The third assumption of the kinetic theory of gases is that the volume of the gas is negligible compared to the volume of the container. So we have volume of gas is negligible compared to the volume of the container. Volume of gas is negligible compared to the volume of the container. The fourth is that the force between gas molecules is negligible. And the fifth is that temperature is a measure of the average kinetic energy of gases. Move haphazardly, they move to and fro. Okay, their motion or their movement is not restricted, it's not tamed because they lack strict parent. So that's it. So the forces between them are negligible, they don't have strict parent. Temperature is a measure of the average kinetic energy of a gas. Ladies and gentlemen, these are the assumptions for the kinetic theory of gases. The next we'll be looking at is the branches of physics. So we have different branches of physics. We have the mechanics. Mechanics basically talks about the branch of physics that is concerned with motion. Okay, so when you were talking about motion, it is referred to as mechanics, or it is a branch of physics that is concerned with motion. Mechanics. The next we have is optics. We have nuclear physics. Okay, there are a lot of branches. We have laser physics, we have sound, we have waves, we have modern physics, and lots more. So all of these are the major branches of physics. So to bring this episode to the end, let us look at a few questions from JAMB regarding the previous episode and this episode. Okay, so the first question we have here is, What does the Greek word physis, from which physics is derived from, mean? A, we have energy, B, matter, C, nature, and D, force. So we had early deduced that physics is derived from a Greek word physis, which means nature. So physics studies natural phenomenon. So the answer to that question is option C. The Greek word physis means nature. The next question: if a solid changes directly into a gas when heat is applied, the process is called. In the previous episode, we talked about the different changes that matter can undergo, that the state of matter can undergo. And we said that a change of state directly from solid to gas is sublimation. But let's look at the option operation. We have sublimation, we have ionization, and we have conversation. So the correct answer there is sublimation. Sublimation is a change of state from solid directly to gas. So the next question says, what is the smallest unit of matter that retains the property of an element? What is the smallest unit of matter that remains or retains the property of an element? A is atom, B is molecules, C is proton, and D is electron. So we had earlier said that matter simply is made up of tiny particles called atoms. So these atoms sum up together to form molecules. So the tiny or the tiniest or the smallest is atom. So making A the correct answer to that question. So for this question, it reads, so in the definition of physics, we had said that physics studies matter and energy, and then we looked at the properties of energy, that energy is conserved. So let's look at this question. The principle that energy cannot be created nor destroyed, only converted from one form to another, is known as A, Newton's first law of motion, B, the law of universal gravitation, C, the theory of special relativity, and D, the law of conservation of energy. So the law of conservation of energy postulates or deduces that energy can neither be created nor destroyed, but can be converted or changed from one form to another in a closed system. Which of the following type of energy is associated with an object motion? A, potential energy, B, kinetic energy, C, chemical energy, D, thermal energy. Potential energy is energy possessed by a body at rest due to position or height. Okay, chemical energy is found in food, batteries, and lots more. Thermal energy, also known as heat energy. So the energy possessed by a body by virtue of movement is kinetic energy. We had discussed that in this episode. So B is the correct answer. Next question, what is the difference between mass and weight? A, mass is a scalar quantity, weight is a vector quantity. B, mass is measured in kilograms, weight is measured in newtons. C, mass is a measure of how much matter an object has, weight depends on gravity. D, all of the above. So ladies and gentlemen, you can agree with me that for the disparities or difference between mass and weight, this is all correct. Mass is scalar, weight is a vector. Mass is measured in kilograms, weight is measured in newtons. Mass is a measure of how much matter an object has, and weight depends on gravity. For understanding of this question vividly, do well to refer to the previous episode. So therefore, D is the correct answer to this question. What is the primary focus of physics as a field of study? A, the study of living organisms and their environments. B, the study of matter, energy, and their interactions. C, the study of ancient Greek philosophy and mythology. D, the study of chemical reactions and molecular structures. Physics primarily focuses on the study of matter, energy, and their interactions, making option B the correct option. Next question. The motion of smoke particles from a chimney is typical of A, oscillatory motion, B, rotational motion, C, circular motion, D, random motion. This question is from motion, of which we'll look at motion in one of the series in physics episode. But note, smoke particles are basically like gases, they move like gases. So the molecules of gases are in random motion from one of these theories. So we can see correctly that option D is the correct answer. Oscillatory motion is a periodic motion, a to and fro motion. Rotational motion is motion that rotates, that has a fixed point, and circular motion is a motion that moves in a circular path. So random motion is a type of motion that a smoke particle would exhibit, making option D the correct answer. Let's take a look at this last question and end this episode. Let's take a look at this question. The molecular structure of a liquid is such that A, the molecular have unlimited freedom of movement. That's supposed to be the molecules. The molecules have unlimited freedom of movement. B, molecular movement is restricted to vibration only. C, intermolecular collisions take place. D, all molecules move with the same speed. So let's look at this option. Talking about the molecules of a liquid. What is the behavior or the properties of the molecules of a liquid? A says the molecules have unlimited freedom of movement. So it is gases that have unlimited freedom of movement. So option D is wrong. It is gases that have that or exhibit that property. They move randomly. Remember, they do not have strict parents. So they are not tamed. And the forces behind them, or yes, the forces that governs them are negligible. Option B says molecular movement is restricted to vibration only. No, it is not restricted to vibration only. It also translates. When we look at motion, we'll see that more extensively. Option C says intermolecular collisions take place. Yes, the molecules of a liquid collide. So let's look at option D. All molecules move with the same speed. No. So remember we said in the kinetic theory of matter, we said that the molecules or the particles of matter moves at varying speed. I think that was the second theory. So option C is the correct answer to that question. Ladies and gentlemen, we have come to the end of this series or of this episode in day 2. Thank you.